Storage classes in C language. Today I'm going to discuss what is a storage class. A storage class are used to describe the features of variables or functions. These features can be the variable of scope, the location where the variable will be stored, the initialized value of a variable, the lifetime of a variable. So if we take the first one into consideration, the variable scope, we have basically two types of scopes in a C language, local and global. In the location of the variable, at which part of the memory the variable is going to be stored, the value which is going to be initialized, is it a garbage value or a default value, and what is the life of a variable. These 4 points are going to consider for storage classes. So if we take the various purposes, we have 4 different kinds of storage classes: auto, extern, static, register. If we take auto, it is a default storage class, the basic thing that we use in every program. Extern is a global variable. Static is a local variable which is capable of returning a value even when control is transferred to a function call. Register is a variable which is stored inside a register. So if we take the next slide, here we can see what is the various structures of a storage classes. If we take the auto, here it is going to be take something like stack registry to store the value, and the value initialized is going to be a garbage value, and the scope is going to be within the block, and the life is going to be once the block is ended, the variable is going to be lasted. If we take same thing extern storage is going to be in data segments, value initialized is going to be 0, it is going to be a global variable, and the life will be there till the end of the program. If we take the next one, static is also a data segment, the value initialized is going to be 0, the scope is within the block, and the life is going to be end of the program. And if we take the final one, register is going to be using CPU registry memory, the value is going to be garbage value, the scope is within the block, and the life is going to be inside a block. So if we take all this into consideration, based on this, the various storage classes are going to be defined. If we take the first one into consideration, auto. As I have said, auto is a normal variable which we are going to use in every program. If I want to declare variable a, so normally we'll be using like int a. In place of that, if we use a variable auto, if we use a storage class auto, int b is one and the same. For example, I'll show you a simple program. See here, you have taken two variables x and y. X is declared as normal way and y is declared as auto int y. So if you see the basic difference over here for both the programs, there is nothing much because both are going to be same. That is what is meaning of auto. And if you take the next one, register, this is going to have some different case. Here if we take this registry, we have to declare the variable by using the keyword called as register. And whenever we declare the variable inside a program, the memory will be randomly allocated at a particular memory. Here if we take the basic difference between the auto register, in auto the memory will be allocated in a random variable, random place where we don't know, whereas for registry the memory is going to be allocated within the address within the CPU registry memory. So if I want to get the address of a normal variable, I can get the address of a normal variable, but if I want to get the address of the register variable, I cannot get, because the memory is going to be stored inside a CPU registry. For example, I'll show you a simple program for this. See here, in this program I'm having two variables, normal auto variables, integer number 1 and number 2, which I have assigned the value 10 and 20, and I have taken a next register variable int num sum, and I am calculating the addition of number 1 and number 2, and I am trying to print the number. Along with this, if I want to get the memory addresses of number 1 and number 2, I am able to get the address values. Whereas if I try to get the address of a register variable, it will not be able to get, because the register variables are going to be stored inside the registry memory. The main advantage if the variables are stored in registry memory are as follows. Whenever the variables are stored in registry memory, the variables are going to be accessed in a faster way. This is the main advantage, because the CPU registry memory is going to be very fast. And next thing is, we cannot declare many variables here, as the CPU registry is going to be limited memory, and we can store points into a registry, the storage of an address. So the next thing is, the value of a register variable by default is going to be 0. There is a difference between the auto variable and the register variable. Next one, if we take the static, one more important storage class. So if we see the static is going to have some peculiar features here. The variables hold the value for the entire program, though it can be declared as a local variable or a global variable. For example, I'll show you a program for this. See here, in this program I'm using two functions, sample and main function. And what I'm trying to do is, I'm trying to call a sample function for 5 times. So whenever we come to a sample function, here I've declared a variable a as static, and I've assigned the value 10. So in a normal program, what happens, when I call a function sample, the variable a is going to be declared and the value 10 is going to be assigned. So next time I'm calling a sample function again the variable a is going to be declared and the value 10 is going to be assigned. Whereas if I declare the variable as static, the main difference is the value is going to be assigned only once. If you see the output of the program, first time the value is 11, that is, first time the value of the variable a is going to be assigned as 10, and the next statement I am incrementing the value of a. So as I am incrementing the value of a, it is going to print the value of a as 11, and I am closing the function. Then it is coming back to the main function, again it is calling the sample function once again. So when the sample function is called for the second time, already the variable a is declared and it is stored in the memory, because it is a static variable. So the statement which is used, that is the first statement, static int a is equal to 10, will not be executed, because the variable a is already declared, which is already stored in the memory, and it is having the value as 11, because once we have incremented, the value becomes 11. So it's going to continue from there. So value of a, when it is incremented the next line, it becomes 12, and it is going to print the value as 12. Same case when I call the sample function for the third time, again the first line is not going to be executed, because the a value is already stored in the memory and it cannot be removed until the program execution completes. Then a value becomes 13 and output is printed. So the basic difference between normal variable and a static variable is, the normal variable, once a program is completed or once the function is completed, the variable life is going to be ended. But for a static variable, the life is going to continue though the function life is ended. There is a difference between a static and a normal variable. Then here comes the last, extern. Extern, we use the keyword extern to declare the variable. The variable extern is a storage class. It is used to give the reference to all the global variable that is visible to all the programs. That is, when we use a keyword extend, the variable cannot be initialized. However, it is pointing to the variable as a storage location that has been previously defined. So here we come back to the example. I'll explain you this. Here I am taking two functions, main and display. And before that I have declared a variable int num is equal to 75. And inside main again I am declaring int num. And I am trying to print the value of num. So initially the value of num is going to be printed as 0. Then when I call a sample display function, in the display function I have used extern int num. That is, take the variable num from the external location. That is, in the global variable I have declared int num is equal to 75. So that value is going to be considered here. And when I print the value of num, it is going to print as 75. That is, the value is going to be taken from the external location. That is a thing that we are going to use as external variables. So whenever the external storage is used, the compiler will define extern is declared within a external linkage elsewhere in the program. So it has to take the value from elsewhere in the program. So it will search where the value is going to be stored. It is going to search and is going to take the value from that location. These variables are declared as extern are not allowed any memory. It is only declared and intended to specify that the variable is declared elsewhere in the program. And one more important thing is the default initial value of extern is 0. Thank you.